Hi, and welcome to another Dante tutorial. This time I'll be walking you through how to create a full nitriding simulation through Abaqus. This will include a nitriding model, thermal model, and a stress model. For this tutorial, I'll be using a ring slice geometry that I'll be provided in the description. You can also find it within the Dante files. To start, I'll launch Abaqus CAE and click with standard/explicit model. Click File and Save and name the file whatever you like. I'll name it Abaqus Nitriding Tutorial. Next, to import the geometry, click File, Import, and Part. Filter for a step file and select the provided cylinder slice axisymmetric step file. Switch to the Parts Attribute tab and select axisymmetric, and then click OK. Switch to the Assembly module, click Create an Instance, and click OK. Switch to the Mesh module and set the object apart. Select Mesh and Controls. Change the element shape to quad and the technique to structured before hitting Done. To seed the edges, select Seed and click Edges. Box select the upper and lower edges of the geometry and click Done. Under Method, select By Size, and under Bias, select Single. Under Sizing Controls, set the minimum size to 0.005 and the maximum size to 2. Click Select under Flip Bias, then box select the upper and lower edges of the geometry and click Done. Select Seed and Edges again, but this time box select the left and right edges and click Done. Under Method, select By Number, and under Sizing Controls, set the number of elements to 2 and click OK and Done. Click Mesh, Part, and click Yes. Under Mesh, select Element Type and set it to Heat Transfer. Click OK. Switch the module to Part, and under Tool, Set, and click Create. Enter all elements as the name, and click Continue. Box select the entire geometry and click Done. Next, I'll create a series of nodes. Switch the module to Assembly, and then select Tools, Set, and Create. Enter all nodes for the name, and check Node as the type. Select Continue, and then box select the entire geometry, and click Done. Next, we'll create a monitor node. Select Tools, Set, and Create. Name it A Monitor Node. Check Node under Type and click Continue, selecting the upper right vertex. Now we'll do the same process again to create some fixed nodes. Under Tools, Set, and select Create. Name this one Fixed Y Nodes. Check Node under Type and click Continue, this time selecting the entire bottom edge of nodes before clicking Done. Next is the Master node. Under Tools, Set, and select Create, naming it Top Y Master Node. Check Node under Type and click Continue, selecting the upper left vertex and clicking Done. Select Tool, Set, and Create. Name this one Top Y Slave Nodes. Check Node under Type and click Continue. This time, select the upper row except for the upper left vertex and click Done. Select Tools, Surfaces, and Create. Enter Exposed Surfaces for the name. Click Continue and box select the right edge and click Done. Now that we're done with the mesh, from here I'll start creating the nitriding model. Right-click Model 1 under the Models tree and rename it. For this tutorial, I'll name it Nitriding Example and then click OK. Go to Plugins and select the Dante Model Builder. Set the model type to Nitriding and click Create Dante Model, clicking Yes. Nitriding should be displayed in the active model header. Select File and Save. Switch to the Materials tab. Set Part Element Sent to Cylinder Slice Axisymmetric. Set Material to SH13XX. Click Add Material section and then click Dismiss. Switch to the Steps tab and modify the step info cells. I'll set the step name to Nitride 1, the previous step to Initial, the time period to 21600 seconds, and the max nitrogen change to 0.00002, and then click Create Step. Now I'll work on the second step. Name it Nitride 2 with the previous step of Nitride 1. Change the time period to 126,000 seconds with the same max nitrogen change. Click Create Step. Check Monitor Node and set it to A Monitor Node before saving. Now I'm going to set up the boundary conditions during the nitriding process. Switch to the Initial/Boundary Conditions tab and click Add Initial Conditions/Predefined Field. Set the field type to nitriding temperature and check constant value, entering 550 degrees Celsius before clicking Apply and Dismiss. Set the field type to total nitrogen weight fraction and check constant value, entering 0 and clicking OK. Click Add Interaction and check constant HTC and enter 0.005, and then enter 0.013 for nitrogen potential and then click Apply and Dismiss. Enter 0.007 for the nitrogen potential, and then set the step to Nitride 2 and click OK. Switch to the Models tab. Save your progress and then click Submit Job. Click Yes to write input file and submit the job. Click Cancel to close out of the DANTE Model Builder for now. Go to File and Open. Set the file filter to Output Databases. Select the newly created ODB file and click OK. The module should switch to Visualization. Click Plot Contours on Deformed Shape to check results. NT11, or temperature, represents nitrogen. You can also set the output variable to SDV-NTGALL or SDV-NTDA. Click Frame Selector to navigate the resulting frames. When you're done viewing the results, click the plus icon to expand Output Databases. Right-click the opened ODB file and click Close. And with that, we can move on to the thermal model. Open up the DANTE Model Builder again and set the model type to Thermal. Enter a new name. I'll call this one Thermal Example. And click Create DANTE Model. Click Yes. And then select Thermal Example as the active model. Click Yes to switch the thermal model, and click File and Save. Switch to the Materials tab and set Part Elements set to Cylinder Slice Axisymmetric All Elements, and then select SH13XX as the material. Click Initial Microstructure and set Ferrite to 0, Perlite to 0, and Tempered Martensite to 1, and then click OK. Click Add Materials section and dismiss. Switch to the Steps tab and modify the following: step name to heating, previous step to initial, time period to 3,600 seconds, and then click Create Step. Now click Nitriding Steps and set the previous step to heating. Click the Nitriding ODB file and click OK. Unlike carbonization models, nitriding process models require mapping in nitrogen gradually, capturing the addition and a buildup of nitrogen to predict residual stress and volume change. This is achieved by mapping in and ramping up to the nitrogen content read from an ODB file. Once it's done processing, you can use the next button to review selected nitriding model frames to map into the thermal model. Click Create Nitriding Steps. Next, modify the following to create the quench step. Step name to quench. Previous step is a nitrogen map 6, a time period of 3,600 seconds, and then click Create Step. Check Monitor Node, and then select a Monitor Node. Save your progress here. Switch to the Initial Boundary Conditions tab and click Add Initial Condition / Predefined Field and set the constant value to 20 degrees Celsius. Then click Apply and Dismiss. Set the field type to Total Carbon Weight Fraction and enter 0.004 for constant value. Then click Apply and Dismiss. Set the field type to Phase Transformation Kinetics and then Kinetics mode constant value to -7 and click Apply and Dismiss. Click Add Interaction and set the constant HTC to 0.0001. Enter 550 degrees Celsius for the constant ambient temperature and click Apply and Dismiss. Expand Thermal Model in the model tree, and then expand Interactions, and then Interactions Constant 1. Expand States, and then right click on any of the inactive steps to activate. All steps should be propagated. I'm going to add another interaction. Enter 20 degrees Celsius for the ambient temperature versus time. Select step and set it to quench, and then click OK. With that, the thermal model is ready to run. Switch to the Models tab and then save your progress. Click Submit Job and then Yes to write the input file. Click Cancel to close out of the DANTE Model Builder for now. To view the results, select File and Open and filter by ODB files. Select the thermal example that we just created and click OK. The module should switch to the visualization. Click Plot Contours on Deformed Shape to check the results. NT11 for temperature should appear, and you can use a frame selector to navigate the results. Under Output Variable, you can also choose SDV hardness. Now let's get started on the stress model. First, click the plus icon to expand output databases. Right-click the open ODB file and click Close. Open up the DANTE Model Builder and set the active model to the thermal example and click OK. For this tutorial, I'll name it Stress Example and then click Convert to Stress. Click Yes and the module should switch to Mesh. Set the active model to the stress model and click Yes to switch to the stress model. Now save your progress. There are several key differences between the thermal and stress model input files: the element type, the mechanical boundary conditions, the dependent variables and user materials, step context such as a static step instead of a heat transfer, temperature history mapped from thermal model to each step, and the stress model controls. Select Mesh and click Element Type. Box select the geometry and click Done. Set Family to axisymmetric stress and uncheck Reduce Integration in the Quad tab. Click OK and Done. For the Static Constraint Boundary Conditions, switch to the Initial/Boundary Conditions tab. Click Add Displacement Boundary Condition and under Set, select Fixed Y node. Check U2 and click OK. Expand Stress Example under Models, then right-click Constraints and click Create. Select Equation under Type and click Continue. In the table, enter the following data. In row 1, set the coefficient to 1, the set name to top Y slave nodes, and the DOF to 2. In row 2, set the coefficient to -1, the set name to top Y master node, and the DOF to 2. And click OK. Now that the boundary conditions are set, we can now run the stress model. Switch to the Models tab and save your progress. Submit job and click Yes. Click Cancel to close the DANTE Model Builder. Now that the model is done running, it's the same process to view the results as before. Select File and Open and filter for ODB files. Select the stress model and click OK. The model should switch to visualization. click Plot Contours on Deformed Shape to view results. S-misses should appear, and you can use a frame selector to navigate the results. You can also change the output variable to U to view the magnitude of displacement, and you can also check U1 or U2 to view the magnitude of displacement along the X or Y axis. Make sure to save your progress and click the plus icon to expand the output databases and right-click to close the open ODB file. And that concludes another Dante tutorial. If you have any questions or have something you want simulated, feel free to comment down below or send us a message at support@dantesolutions.com. Thank you for watching and happy simulating.